This video is for class 9 physics and today we are doing characteristic properties of upthrust. Before watching this video, you should have watched the other two videos. If you haven't, then please watch those two videos on the topic of thrust, right? And then come back to this video. So the upthrust has the following three characteristic properties. Number 1, larger the volume of the body submerged in a fluid, greater is the upthrust. Number 2, for same volume inside the fluid, more the density of the fluid, greater is the upthrust. Number 3, the upthrust acts on the body in the upward direction at the center of buoyancy, that is the center of gravity of the displaced fluid. Okay, let us deal with them one by one. So going to the first topic, right, which is larger the volume of body submerged in a fluid, greater is the upthrust. So in the experiment of pushing an empty can or cork or a ball into water as described above, here as described above means those two videos, okay, those two topics which I have already seen, or those two topics which I have already discussed. It is experienced that the upthrust on the body due to the water increases as more and more volume of it is immersed into water till it is completely immersed. So when it is completely immersed, we shall get the upthrust, which is Fb dash, right, which is always more than the upthrust for partially immersed object. So similarly, when a bunch of feathers and a pebble of same mass are allowed to fall in air, the pebble falls faster than the bunch of feathers. The reason is that upthrust due to air on the pebble is less because the volume of the pebble is less than that on the bunch of feathers because the volume of the feathers is more, because the volume of the pebble is less than that of the bunch of feathers of the same mass. However, in vacuum, both the bunch of feathers and pebble will fall together because there will be no upthrust, right? No air, no fluid, no upthrust. Okay. Now explaining that paragraph, suppose we consider one pebble and we can consider a bunch of feathers, right, having same mass, that is m and m, having same mass, that is m and m. When they are made to fall, okay, when they are made to drop in air, suppose these small dots here, this dots here, this dots here, they represent the small molecules of air. So when these two things are falling down, right, then what will happen is they will get submerged in this air. So when they get submerged in this air, obviously they will experience one upthrust, they will experience some upthrust. Now the upthrust experienced by the feather or the bunch of feathers is much more compared to the upthrust experienced by this pebble, although having same mass, because the reason is, okay, the reason will be that the upthrust experienced by the feather is more because the volume of the feather is more, right? More the volume of the feather gets submerged in air, more will be the upthrust experienced by the feathers, right? But here if I talk about pebble, as the pebble goes down, right, more of it gets submerged in the air, but still the upthrust will be much less compared to the feathers because the volume of pebble is much smaller compared to the volume of feathers. That is also the reason why the pebble will fall faster than the bunch of feathers. So this pebble will fall fast, right, it will come very fast, while these feathers will take some time to come down. Okay, is because of the upthrust acting on them are different, right? I hope you understood this paragraph. Now we can go to the next point, that is point number 2 from your book. So coming to the next point, that is for same volume inside the fluid, more the density of liquid, greater is the upthrust. Okay, if we place a piece of cork A into water and another identical cork B into glycerin or mercury, we notice that the volume of cork B immersed in glycerin is smaller as compared to the volume of cork A immersed in water. So obviously cork B is experiencing more upthrust, that's why its immersed part is smaller, whereas the upthrust experienced by this cork will be less as the volume of this cork A immersed in the water is more, right? So the reason is that the density of glycerin is more than that of water. Now if you want to immerse cork B in glycerin to the same extent, okay, as cork A in water, then an additional force is needed on the cork B to immerse it to the same level as cork A. This shows that for same volume of the body inside the liquid, a denser liquid exerts a greater upthrust. Okay, so here the bottom line is, okay, that denser liquid exerts a greater upthrust. That's the basic thing we need to understand from this paragraph, right? Now the last point, that is point number 3, the upthrust acts on the body in the upward direction. Okay, the upthrust acts on the body in the upward direction. Till here we understand the upthrust always acts in the upward direction. Now the question comes, where should it act? It should act at the center of buoyancy. Now what is center of buoyancy? We need to understand. That is the center of gravity. Again another, what is center of gravity? So we have 3 questions here. First thing, where should it act? They are telling us it should act at the center of buoyancy, right? Now we have the question, what is center of buoyancy? Now again they are telling that is here means the center of buoyancy is the center of gravity. Now again, what is this center of gravity of the displaced liquid? Now which displaced liquid? Okay, let us try to understand these few things first, then we can come to this point and try to understand whole thing of this paragraph. Okay, let us go to the blank page now. Let us try to understand what center of gravity means. This we had discussed in the chapter of gravitation also. Let us consider an object. Suppose we consider this as an object. Now this object should be made out of many molecules, right? And each molecule needs to have some weight. Okay, so suppose each one of them are having W1, W2, W3, W4, W5, etc. weights. Then what happens is all this weight of the object lie at one point of the object, right? And here the whole weight of the object lies. This point where all the weight of the object lies, or the point where the object can be balanced, is called center of gravity. Center of gravity. I hope you understood what center of gravity is. Now this we have discussed in the previous videos also from the topic gravitation. Now let us understand the center of buoyancy. Let us consider one beaker, okay, filled with a liquid, right, up to one level till here. Okay, so this is the initial level. I can say this is the initial level of the liquid, initial level, right? Level 1, that is the initial level. Now suppose I immerse one object here, okay, a ball completely immersed. So under this condition, what will happen is, as you all know, the level of the liquid should rise. The level of the liquid should rise. By how much? by the volume of the ball immersed in it. Okay, now we have level 2, that is the second level of the water or the liquid, level 2. So here you can see this portion of the liquid has been displaced by the object. Now as you all know, this displaced liquid should have some weight, right? If it has some weight, it should have the center of gravity also. This center of gravity of the liquid, okay, of the displaced liquid, in fact, will have actually is known as center of buoyancy. Okay, this I cannot fit the whole spelling here. It's called center of buoyancy. Okay, so center of buoyancy is the center of gravity of the displaced liquid. Okay, so I hope you understood this few things. Okay, now let us go to the book again. So coming back to the book, for a uniform body completely immersed inside a liquid, the center of buoyancy coincides with the center of gravity of the body. Okay, let me try to explain this here. See, they are telling us to go to figure 5.1. Let me try to explain this. Okay, now consider an object. Okay, here this is an object. Now this object should have some center of gravity here, right? This point here can be considered as center of gravity, CG, right? Now if some object is completely immersed as shown in the figure, it should have center of buoyancy also. The liquid should have center of buoyancy also. That center of buoyancy in this case actually coincides with the center of gravity. So center of buoyancy and the center of gravity, are at the same point when the object is fully immersed in the liquid. So I hope you have understood this. When an object is fully immersed in a liquid, its center of gravity will coincide with the center of buoyancy, or I can say the center of buoyancy coincides with the center of gravity of the body. Okay, now let us try to understand the next line, which says, but if a body floats in a liquid with its part submerged, the center of buoyancy B, right, is at the center of gravity of the displaced liquid, that is the center of gravity of the immersed part, part of the body, which lies below the center of gravity G of the entire body. The weight of the body W acts downwards at G, while the upthrust FB acts upwards at B, such that W equals to FB, because the body is floating. Okay, now if I consider this figure, right, here you can see some part of the body is immersed inside the liquid, right? Now this much part, okay, this much part of the body which is immersed, right, will have a different center of gravity compared to the whole object, here, right? So the center of gravity of the immersed part will be somewhere around here below, right? So this center of gravity of the immersed part of the body is also equal to the center of gravity of the displaced liquid. So this becomes the center of buoyancy here, Now it should lie just below the center of gravity of the whole body, which is denoted by capital G, right? Now the whole weight of the body should lie downwards, right, and the upthrust should lie upwards. Okay, I hope you understood this particular point. So this much for this video. Thank you so much.